Hi, Mr. Boer here for the last segment, Geology for Geo Time, week 5. Left off talking about radioactive decay and the idea how we can find a numeric time or an absolute dating. We can actually figure out how much time something has been either formed, such as a rock, or how long ago it died, based off of the radioactive decay. You have to know half-lives, though. Like I said, it's a matter of figuring out how much parent and how much daughter there is. And when it's first made, it's 100% parent. Then it's going to start to decay into what we call the daughter. So, and one half life, you'll have half the parent in half of the daughter. And then half of that will decay. And you would have 3/4 of the parent and only 1/4 of the daughter. And you notice that I'm going to take half of that. So you're going to have 7/8, and then you're only going to have 1/8 after 3 half-lives. So number is first figure out how many half-lives there have occurred, and then you have to know the basis of each one. How long does it take for half of that to decay? Because the amount of time it takes to go from this half to this half is the same, even though not the same amount of particles change. That's the whole process of that closed system in order for us to take it's a clock. So if I say each half-life was 5,000 years, and I know there were 2 half-lives that have occurred by looking at the number of parent and daughter, that's 10,000 years old then. So there, and I said, there's a few examples you'll be able to find on the videos and be able to look up how to use radiometric dating. And you can combine radiometric dating or absolute dating with relative time dating to figure everything out. And that's what geologists have done over the last 100 years, is by looking at these different formations, saying this one's older than that one and then older, and then using some igneous volcanic eruptions, correlating it all over the world to find out what layers they hit, and then figuring out an actual age. So what we're going to focus on next week is going to be the geologic time scale. The oldest would have been found on the bottom up to the top, and then eventually we put years with that based off of their radiometric dating. It starts to get a little complex with radiometric dating, but we do try to keep it a little bit simple. Notice one of the main ones we use is carbon-14. It's called carbon dating because it only has a half-life of 5,730 years. So you can use that to figure out ages of prehistoric animals and fossils that we have found. Rocks wouldn't work as good because we know rocks, it could be a lot older. So you got to use uranium and some of the other ones that have longer half-lives to figure out the ages of rocks. But, here's just a sample of what we get into. Notice the geologic time scale, bottom to top. This is older than that, so we still use superposition and things. And then we gave names based off of the major evolutionary changes throughout organisms. And then we've put now time dates, how many million years ago, based off of the radiometric dating. So the geologic time scale is a combination of everything that we've put together with geologic time. And we'll focus on that next week and talk about some of the organisms that go hand in hand with each eon, era, or period. So if there's any questions, just email mark.boer@addisonschools.us. Don't forget to look at the videos, the full PowerPoint, and if you have any questions, make sure you get a hold of me, and we will see you next week.